Algebra 1, we're continuing on in factoring. Last time we were together, we factored the polynomials that look like x squared plus bx plus c. In a nutshell, you need to find two numbers that multiply to c and add to b. Now, if you can't find them, it's not factorable. But if it can be factored, those are the properties of the numbers. Once you get those numbers, you go straight to your factorization. We also factored the trinomials that had two variables that look like this, same thing. You're looking for numbers that multiply to c and add to b as well. Now, sometimes with factoring, we have to use multiple methods. And we started out with the greatest common factor because you should always, always, always ask if the greatest common factor will work. So when I look at something like this, the greatest common factor is 3x. That leaves me with x squared plus 5x minus 6. So now I have used the GCF, but now I have to figure out, how do I factor this? Well, I have a factoring method for this. I need numbers that multiply to -6 and add to 5. So those numbers are 1 and 6, with the 1 being negative. So this final factorization is 3x, x minus 1, x plus 6. So again, what I had to do there, I had to string together two different methods of factoring: the greatest common factor and our factoring of trinomials, okay? So that should be the case all the time. If you see a number in front of the leading coefficient that's not a 1, see if you can factor that out. So in this one, the greatest common factor is 5. That leaves me with x squared minus 7x plus 10. So now I need numbers that multiply to 10 and add to -7. So that's going to be a 2 and a 5, with both of those numbers being negative. So 5, x minus 2, x minus 5. Greatest common factor here is 6x, and that leaves me with x squared plus 5x plus 4. Numbers that multiply to 4 and add to 5 are what, 1 and 4. So this factorization is 6x, x plus 1, x plus 4. So again, without the instructions, you should always, always, always see if there's a greatest common factor, okay? Now, let's look at the binomials 3x plus 4 times 2x plus 1. So 3x times 4, 2x plus 1. So when I multiply that out, I get what, 6x squared, 8x, 3x, and 4. So this is 6x squared plus 8x plus 3x plus 4. So if I look at this, this is 6x squared plus 11x plus 4. Now I've got to figure out, how can I go from something like this back to the factorization? What's different here is there's not a common factor other than 1, so I really can't factor out the 6 to get down to an x squared term. So what we need to do in this particular case is I need to look at these two numbers, okay? What I need here are numbers that multiply to 24 and add to 11. So factors of 24, 1 and 24, 2 and 12, 3 and 8, 4 and 6. That's the way to get them to add to 11. And what you're seeing here is, when you look at that 3 and the 8, they're showing up right there. So what I need to do is I need to rewrite this problem that you see right here is 6x squared. Take these numbers right here, plus 3x plus 8x plus 4. So all I did was I rewrote that problem. Instead of the 11x, I wrote 3x plus 8x. Now what I can do, because see, when I get this 3 and 8, I can't say my answer is x plus 3, x plus 8, because that's x squared plus 11x plus 24, which is not what I'm working with. So what I do is once I get the numbers, I'm going to rewrite the problem, and then I'm going to use the GCF, okay? So what is the GCF here? The GCF here is 3x, and that leaves me with 2x plus 1. Copy down that plus sign. Now, what is the GCF here? That's 4, 2x plus 1. Now what you notice is there's a 2x plus 1, there's a 2x plus 1. Factor out the 2x plus 1. When you factor out the 2x plus 1, you're left with 3x plus 4. That is my factorization. Okay, we're going to do some more practice on this because a little bit more moving parts than what we did. So when we look at something like ax squared plus bx plus c, I need to find numbers that multiply to ac and add to b. I take those numbers and I rewrite this problem so that I can factor by grouping, okay? And that's the one that we just worked. So let me just work it again for you so that you see that. So all I do is I need numbers that multiply to 6 times 4, which is 24, and add to 11. Those numbers are 3 and 8. So it doesn't matter the order, but I just have to rewrite this problem. Let me just write it differently than I did before. Before I did 3 and then the 8. Let's do the 8 and then the 3. So all I did is I rewrote this problem. So instead of 11x, I've written 8x plus 3x. Now if you do this, you're guaranteed that you can factor by what's known as grouping. So factor this by groups. What is the GCF of the first two? Well, the GCF there is going to be what? 2x, and that leaves me with a 3x plus 4 plus 3x plus 4. Both of these terms have a 3x plus 4. The coefficient here is a 1. So when you factor out the 3x plus 4, you're left with 2x plus 1, and that's your factorization. Let's do a few more examples here. So again, there's no greatest common factor. I need numbers that multiply to 30 and add to 17. 1 and 30, 2 and 15, and that's it. So rewrite the problem. 10x squared plus 2x plus 15x plus 3, and then we factor it in groups. The GCF of the first two terms is 2x, and that leaves you with 5x plus 1. Copy down the plus sign. The GCF of the next two terms is a 3, and that leaves me with 5x plus 1. This final answer is 5x plus 1 times 2x plus 3. Here I need numbers that multiply to 2 times negative 21, that's negative 42, and they add to 1. So I can think off the top of my head, that's going to be a 6 and a 7, with the 6 being negative. So this is going to be 2x squared minus 6x plus 7x minus 21. Factor out a 2x. That leaves you x minus 3. Copy down the plus sign. Factor out a 7. That leaves you with an x minus 3. Final answer is x minus 3, 2x plus 7. Here I need numbers that multiply to negative 24 and add to 5. So what is it? 1 and 24, 2 and 12, 3 and 8. That's going to be it. And to get these numbers to add to that, it's going to be a negative 3. So 4x squared, and again, the order doesn't matter here, plus 8x minus 3x minus 6. First two terms, factor out a 4x, and that leaves you with x plus 2. Now, very important, whatever this sign is, copy it down. It's a minus sign. Now, just look at the 3 and the 6. They have a 3 in common, but technically it's a negative 3. I've already taken care of that. What do you multiply negative 3 by to get negative 3x? That's x. What do you multiply negative 3 by to get negative 6? That's plus 2. Okay. So now this final answer is x plus 2, 4x minus 3. Now in this one, I can look and say, okay, 15 times 40 is what, 600? Or I can say, is there a greatest common factor? So it looks like I can factor a 5 out of this, and that leaves me with 3x squared minus 14x plus 8. Now I need numbers that multiply to 24, much smaller number, add to negative 14. So what, 1 and 24, 2 and 12, and that's going to be it. If both those numbers are negative, they multiply to 24 and they add to negative 14. So this is 5, and then you've got 3x squared minus 2x minus 12x plus 8. Here you can factor out a 2x. So 2x, excuse me, you can only factor out an x there, I'm sorry. Factor out an x, that's 3x minus 2. Copy down the minus sign. The 8 and the 4, 8 and 12 have a 4 in common, but it technically is a negative 4. What do you multiply negative 4 by to get negative 12x? That's 3x. Negative 4 to get positive 8, that's negative 2. So this is 5, 3x minus 2, x minus 4. The other thing you want to try to do is anytime the coefficient in front of the first term is a negative, it gets a little bit cumbersome to do that. So it's probably best to just factor out that negative. Let's just write this as 12x squared plus 5x minus 2. Okay. Now I need numbers that multiply to negative 24 and add to 5. So I think that's going to be the 8 and the 3, with the 3 being negative. So I've got negative, and this is 12x squared plus 8x minus 3x minus 2. I can factor out a 4x, 3x plus 2. Copy down that minus sign. There's nothing to factor out of the 3x minus 2, but when I factor out the negative, this is what, 3x plus 2. So your final factorization here is what? 3x plus 2 times 4x minus 1. Same thing here, and this is what we did, okay? So I could have done it the other way without doing that. If I do, let me just move this over. So I factored out the negative, and that's what I did right here. If I did not factor out the negative, okay, so if I did not factor out the negative, and I just look at this problem as it is, I'm looking for numbers that multiply to negative 24 and add to negative 5, so that's an 8 and a 3, with the 8 being negative. So it's a negative 12x squared minus 8x plus 3x plus 2. Then I can factor out a negative 4x, and that gives me 3x plus 2 plus 3x plus 2. So this is negative 4x plus 1 times 3x plus 2. It just means you've got a negative in front of your x term, and that is equivalent. If you distributed that negative to that parentheses, you get negative 4x plus 1. It is just easier if you make the coefficient of the x squared term a positive number, okay? So there's plenty of work here to practice on this. Like I said, it's got a little bit more involved than the ones that start with a coefficient of 1x squared, okay? But there's a process for doing it, and listing out factors and then rewriting so you do the factor by grouping.